All right, guys, big test tomorrow. I want to take a little bit of time and go over this review. I know some of you are going to be joining me at about 6:15 this evening to review together if you need it. But I thought that I would go over this and post this first in case maybe this would help some of you out. So I'm not going to go over every problem. I'm going to go over one or two per type and see if that helps you guys. So for number one, it says to complete the table of values for the function. So this is a quadratic. It has an exponent of 2. I would recommend, if you haven't already, to download Desmos onto your phones, or if you have it on your Chromebooks, that's awesome. So we're going to put a parenthesis, and then we're going to put an x, so -3. And then it says +1. End my parenthesis, and then I'm going to press the squared key. So when I do that, I get a 4. And then I don't want the -3 anymore, so I'm going to go over there, and instead I want a -2. When I do a -2, I get a 1. Instead of a -2, I want a -1, and I get a 0. And then I don't want a -1, I want a 0, and I get a 1. And when I plug in a 1, I get a 4. So there's my table. So I'm going to add to this problem because you kind of need to know it for your test tomorrow. So once you have your table, then I'm going to ask you to identify these 4 things: vertex, axis of symmetry, domain, and range. So what you're going to do then is you're going to want to graph this on using your phone. So you're going to go to, and this is what the graph looks like. So if you look here, this is your vertex. It's at -1, 0. That's your vertex. Axis of symmetry is the line that cuts the graph in half, and it's always x equals the x value of your vertex. The domain and the range is how far, domain will always remain the same for all of these. It's -infinity to +infinity. You won't have to worry about remembering that. Like, that's just something that's always true. Range, you always write how far down to how high up. So if you look at your graph here, the lowest it goes is 0. So 0. And then we don't know how high it goes, so it's infinity. So that's how you do problem number 1. Same ideas. You're not going to be able to do vertex and that kind of thing for number 2, but if you needed to, if it were a absolute value or a quadratic, you could. Just make sure you know what those terms mean. For 4, 5, and 7, now we're to these absolute value graphs, and we're not really, I mean, we can talk about graphing them. I'm not concerned with you actually graphing them. I'm concerned about you describing the translation, figuring out what the new vertex is, and then going with, again, with the axis of symmetry, the domain, and the range. I'm only going to do the vertex, axis of symmetry, domain, and range for number 7. The rest of these, I'm just going to describe the translation. So for number 4, when you have the plus or minus or addition or subtraction inside the bars, that's left or right, and it's actually the opposite direction that you would think. So this one actually moves left 4, and that is it. The new vertex would be -4, 0, because it doesn't move up or down any, it moves left 4. This here, when the addition or subtraction is outside the bars, that's moving up or down. This one does not move left or right any because it's not inside the bars, but this does move down 5. So this actually would have a vertex of 0, -5. For number 7, we are going to do the whole kit and caboodle here. So x -2 in the bars means that it moves right 2. +1 outside the bars means it moves up 1. So we have a few things that we are going to list here. So the vertex, since it moves right 2 up 1, that's a +2, +1, so 2, 1. Your axis of symmetry is always x equals the x value of your vertex. No matter what, always the x value of the vertex. So whatever that is, you kind of just go with that. And you can plug this again into Desmos to help you out if you want to see what these graphs look like. Domain, no matter what, again, is going to be -infinity to +infinity. And then the range that is where you may want to have it graphed. So we're going to do, okay, we have absolute value, so there's my absolute value bars, x minus 2, and then outside the bars plus 1. So there's what my graph looks like. So the range, how far down does it go? It goes down to 1. That's the lowest it goes is 1. And then we don't know how high it goes, so infinity. So hopefully that helps with that chunk. Let's move on to the next page. Let's look here. All right, so again, we're not going to do all of these. I'll probably just do 9, 11, and 13. So we just need to write the translation. So it's actually going backwards. So it says 1 unit up, 2 units left. So 2 units left is inside the bars. Left is actually plus. 1 unit up is outside the bars, and that's plus. So that's all it wants for that one. Number 11, we have the negative sign out front, so we're going to leave that guy alone. And inside the bars is left and right, so this says 1 unit right, so it'd be minus 1. 3 units up would be plus 3. And just leave it like that. For 13, there's nothing outside the bars, so leave that alone. 3 units left is plus 3 inside. 2 units down is minus 2 outside. And that's it, guys. Don't make them any harder than they are. For the 15, 16, and 17, they just want you to describe the translation and to actually write the equation. I'm going to do 17 for you because this is the hardest one of them all. So I would personally describe it first, and then that will help you. Once you have it described, then it's kind of like these ones up here. So for 17, you move left 2, up 1. From 0, 0, you move left 2, up 1. So then if I go to write my equation, left 2 is x plus 2. Up 1 is plus 1. So there's my equation. So I personally think it's easier once you have the translation described to write the equation. So I would describe it first. 18, 19, and 20. Now you are writing the equation for the graph. So when you are writing the equation, you do need to know how your vertex moved, but you also need to know your slope. So you need to know your slope and then also how does it move or how does it translate. So the slope, to do that, and we'll do these two. To do the slope, you go to your vertex and then you find another good point. So another point where it crosses at a corner. So those two right there. So to get from here to here using rise over run, you go 1, 2, 3 up and then 1 to the right. And 3 over 1 is 3. So that 3 is what's going to go outside of the absolute value bars. Now, how did your vertex move? So here's 0, 0. We didn't move over any, but we moved 1, 2, 3, 4 down. That's it. Okay. So now we're going to write our equation. Y equals, your slope goes on the outside, x inside. Left and right is inside with the bars. Well, we didn't move left or right, so leave that, just end it. 4 down means minus 4 on the outside. So that is how you write that equation. Let's take a look at 19. Same idea. I'll even switch colors to keep it interesting for you guys. We need to find our slope. So here's a good point, and then here's a good point. So to get from here to here, you go up 1, and then 1, 2 to the right. And just leave it as 1/2. Now, how does your vertex move? So from 0, 0, it moved 2 to the right. It didn't move up or down any. So now to write our equation, y equals slope, absolute value of x. Now it does move 2 to the right, so you put minus 2. And then it doesn't move up or down any, so leave it like that. And I'll do one more for you. Let's take a look at this guy right here. For number 20, we're going to find our slope first. So from here to here, we go up 2, right 1. 2 over 1 is 2. Then how do we move? From 0, 0, you go 1, 2, 3 to the left, and then down 1. So then, now to write your equation, you do y equals, put your slope outside, absolute value bars in an x. 3 left is plus 3 inside the bars. Down 1 is minus 1 outside the bars. Hopefully that helps a little bit. There's a decent amount of these types of problems tomorrow, so you need to make sure you know what you're doing there. For 21 and 22, you have to determine whether these are linear or nonlinear. Linear means that your graph follows a pattern. Your table follows a pattern using addition or subtraction. Nonlinear means it doesn't. So like for here, to go from 24 to 20, you go down 4. 20 to 16, you go down 4. 16 to 12, down 4. 12 to 8, you go down 4. So far, so good. Check your x's. 0 to 2, you go up 2. 2 to 4, you go up 2, up 2, up 2. So because that they are doing like a pattern here, this is linear. Write your equation. You're going to write your equation in point-slope form. That's the only form we've ever used this unit. Some of you keep writing it in slope-intercept form. You need to stop doing that. I don't think that you're actually getting it into slope-intercept form. So if you write it in slope-intercept form tomorrow, it will be marked wrong unless you have the work to support it. You have to submit work tomorrow for your test to get graded. So that will also be a question on your test. You'll see what I mean. So for your point slope form, it's y minus y1 equals m x minus x1. x1 and y1 are going to come from the first point here. There's your y1, there's your x1. And then your slope is going to be the change in y over the change in x's, which is -2. So we're going to do y minus the y equals m -2 x minus the x. You've been doing point slope form now for months. And then here to check, first thing we're going to check and see if it's linear or not linear. To go from 9 to 6, you go down 3. 6 to 3, you go down 3. 3 to 6, you go up 3. So right away, we already see that it is not following the same pattern. So this is nonlinear. So for the equation, we're going to write none. For 23, we just did these. We just did that here. So I'm not sure if we necessarily need to do that. This is your vertex. I'll do it anyway. Your vertex is 20, 0. Axis of symmetry is always going to be x equals the x value of your vertex. Domain, it's not a story problem, so your domain is always going to be -infinity to +infinity. And then the range, how far down does it go? It hits at 0. This is how far down, 0. And then we don't know how high up it goes, so infinity. 24, we have a story problem. So story problems, you have to be a little bit more careful. For 24, it says, for what values of x is the graph decreasing? So the graph is going down here, but these are your x values. So from 0 to 25, the graph is going down. It says, Olivia said the range is 25 to infinity. Is she correct? No, Olivia is wrong. How far down the graph goes is 0. How high up the graph goes is 10. So is she correct? No, this is what the range should be. It says, during what time interval is the distance increasing? So we're increasing from 25 to 50. And then it asks, what is the vertex? Well, this is the vertex right here. From 0, 0, I go over 25, up, down, 0. I'm going to add another question to this. I'm going to ask, what is the total distance traveled? Just because I feel like that popped up on your guys' quiz. So the total distance traveled here, from 0 to 25 minutes, she traveled 10 miles. From 25 to 50 minutes, she traveled an additional 10 miles. So Olivia rode the bus, I think this is a bus, for a total of 20 miles. That was a little bit, this is a little bit lengthier than I would have liked to this have been, you guys. I'm sorry, but I do hope that that helps prepare you for your test tomorrow. Test will be open at 12:01, closes at 11:59. You must submit work in some way, shape, or form. Work is there to help you out. I grade your work and then I grade your test. So please make sure that you are writing your answers down. I will make sure you have sufficient amount of time to take your test. Your test only has 9 questions on it, so please make sure that you are doing your best. Good luck!